do things get heated up to the point where they catch fire? Like an Apollo spacecraft re-entering the Earth's atmosphere. Right. Here, it's friction. The work of air particles pressing and rubbing against surfaces that are moving at tremendous speed. And it's friction that produces the heat that lights matches. You can use metallic sparks for ignition. Electric sparks will ignite flammable gases too. There's at least one more method of ignition. If you've ever pumped up a bike tire with a hand pump, you've probably noticed the heat the pump generates. If you could put hundreds of pounds of pressure on it, the metal would get hot enough to burn you. What happens is that the increased pressure crowds the molecules together so that they collide more often. It's a form of friction, again, producing heat energy, actually enough to ignite fuel. It's called compression ignition, and is the principle used by the diesel engine, invented by a German engineer, Rudolf Diesel, over 80 years ago. Today, you find diesel engines everywhere, wherever there are big, tough jobs to be done. The huge highway haulers and buses, cross-country locomotives and little switchers, too. Boats, ships, and harbor dredges. Earth movers, agricultural and mining machinery. Construction jobs, driving air compressors and operating cranes. And for driving electric power generators for both regular and emergency service for hospitals, broadcast stations, and telephone systems. Because a diesel engine is an internal combustion engine, it looks rather like a gasoline engine. It has pistons, valves, connecting rods, a crankshaft. The pistons go up and down, and the crankshaft goes round and round. In a 4-stroke cycle or a 2-stroke cycle diesel engine, there are the repeating stages of intake, compression, power, and exhaust. But that's about where the similarity ends. The diesel is a simpler engine with fewer parts. It does not have, nor does it need, many of the familiar parts of the gasoline engine. First of all, the fuel is different. It's not gasoline, but fuel oil, or diesel fuel, as it is sometimes called, a refined distillate of crude oil. It costs less than gasoline. There are no spark plugs in a diesel engine because ignition is by the heat of compression. Without plugs, there's no need for electrical parts such as a spark coil, wires, distributor, or electronic ignition components. You won't find a carburetor on a diesel either. Instead, each cylinder has a fuel injector. It sprays the fuel into the cylinder. A 4-stroke diesel engine operates with the same cycle as that of a 4-stroke cycle gasoline engine. Intake draws in a mixture of fuel, gasoline vapor and air in the gasoline engine. It's air only in the diesel. Compression comes next, much higher in the diesel than in the gasoline engine. Ignition occurs near the top of the piston travel when fuel is injected from the injector, producing the power stroke. The exhaust stroke drives the burned gases out of the cylinder, and the cycle repeats. Many diesel engines are designed to operate on a 2-stroke cycle, which has several advantages over the 4-stroke type. The 2-stroke diesel works without intake valves, but does use regular Papa-type exhaust valves in pairs. Ports are used for admitting air into the cylinder, air that is supplied by a blower. And that's it, the basic parts of a 2-stroke diesel. Let's see how they work together. At the bottom of the stroke, the exhaust valves are open, the ports are uncovered, and air is pouring in, driving out the burned gases from the previous stroke. As the piston rises and closes off the intake ports, the exhaust valves close. Compression now takes place, high compression. The amount the air is squeezed ranges from 1/12 to about 1/20th of the volume it had when the piston was fully down, depending on the size of the engine. The compression ratio can thus be from 12 to 1 to 20 to 1 in different diesels. As the air is squeezed, its pressure rises to between 400 and 600 pounds per square inch. The fuel in the injector must therefore be at even higher pressure in order to enter the cylinder. At the top of the stroke, maximum compression, the air's temperature shoots up to about 1,000 degrees Fahrenheit, well above the fuel oil's ignition temperature. Consequently, when the injector shoots its spray of fuel oil into the cylinder, it ignites immediately, spontaneously. The heat energy thus released provides the power that drives the piston, connecting rod, and crankshaft. As the piston nears the bottom of the stroke, the cycle starts all over again. You can say that the two strokes are compression, power, compression, power. The two-stroke cycle is well suited to the diesel-type engine. One benefit is high torque, the crankshaft's twisting power. With it, the engine takes on additional loads with little or no loss of speed. Also, with power being delivered on every other stroke, there is smoother performance than in a four-stroke system. In addition, there is rapid acceleration because of the frequency of the power strokes. Each cylinder has a fuel injector and usually 4 valves, operated by a camshaft that is driven by the crankshaft. A 2-gear drive would call for very large timing gears, as they are called, because of the distance between the shafts. An intermediate or idler gear solves the problem. Some engines use a chain drive for the same reasons. The gear ratio is 1 to 1 in a 2-stroke engine because the valves and the injector must be operated once for each revolution of the crankshaft. This gear system is also used to drive the blower, which is a positive displacement air pump. It provides an even flow of air to all intake ports. The exhaust valve train is similar to that in a gasoline engine. Cam, cam follower, push rod, rocker arm, and valve. As in some gasoline engines, some diesels have an overhead camshaft, which eliminates the need for the push rod and its cam follower. Whichever type is used, the system operates in the same way as in a gasoline engine, with the springs serving to return the valves to their closed positions when the cam action is completed. The heart of every diesel is the fuel injection system. Some engines have a central high-pressure pump and high-pressure supply lines to the injectors, which are operated mechanically by a cam system. Return lines carry the unused fuel back to the supply tank. In another system, the fuel is pumped under low pressure to a common fuel supply pipe that feeds individual high-pressure pumps, each pumping a metered amount of fuel to one injector. A third type uses unit injectors. Each injector is also a high-pressure pump. A low-pressure pump supplies all the injectors with fuel oil from the supply tank. A return manifold carries the unused fuel back to the supply tank. Each unit injector is a highly precise mechanism that delivers a small but highly exact quantity of fuel to the cylinder at the right moment in the cycle. The injector is operated by a cam, push rod, and rocker arm mechanism similar to that in the valve train. The principal parts of the injector are the plunger, which does the high-pressure pumping, the follower and return spring, a rack and gear for rotating the plunger, the injection valve, and the spray tip with holes nearly as small as the diameter of a human hair. The control rack is positioned by the throttle. Turning the plunger regulates the amount of fuel that is injected on each stroke. A governor controls the idling speed and the maximum speed of the engine. When the cam raises the push rod, the rocker arm presses the plunger down, first admitting fuel to the chamber, then cutting it off, thereby exactly measuring or metering the flow to the exact quantity required. The fuel oil is pressurized, up to as much as 20,000 pounds per square inch, so that it opens the injection valve, allowing the fuel to flow out of the spray holes. To prevent leakage under the high pressures, the clearances are extremely small, down to only 50 millionths of an inch, making the unit injector one of today's most precise mechanical devices. Like gasoline engines, diesels must be kept cool and lubricated to prevent damage from friction and heat. The cooling system is a kind of jacket of water or antifreeze coolant surrounding the cylinders and piped to a radiator. A pump circulates the coolant through the system so that the radiator can remove excess heat from it. A fan assures the proper flow of cooling air through the radiator, just as in a gasoline engine. Engine lubrication is provided by oil. It is pumped from the engine's oil pan up through the bearings, the crankshaft, connecting rods, and piston pins, from which it flows onto the cylinder walls and drops back into the oil pan. The system also lubricates all parts of the camshaft system and the blower drive mechanism. A cooler keeps the oil from being overheated by the hot parts of the engine. An electric starter motor is usually used to crank the engine, using power from a heavy-duty battery. A generator or alternator keeps the battery charged. Today, diesels are available in sizes suited to any job, large or small. They may have from 1 or 2 cylinders to 6 or 8, or even 16 cylinders in the same unit. Rotating speeds, RPMs, may be low, medium, or high. There may be 1 piston in a cylinder, or 2, with a common combustion chamber. Cycles, 2-stroke or 4-stroke. The cylinders may be inline, V, or radial. Diesels are larger and heavier than equivalent-powered gasoline engines. The stronger construction is needed mainly because of higher internal pressures resulting from high compression and compression ignition. Because of its size and weight, the diesel engine is more costly. It does not provide the flexibility, quiet operation, and performance preferred by most passenger car buyers. Diesels have definite advantages when used in heavy-duty applications. First is greater efficiency, much greater than can be gotten from any other type of heat engine. Next is fuel economy. Less fuel is required to produce the same amount of power at the shaft. Also, a wide range of fuels can be used, depending on engine size and design. Diesels also have another advantage. They are low emitters of air pollutants. If you see some that produce objectionable smoke, it means that the engines are old and badly worn, or that they need good maintenance or overhaul. Diesels are the strong guys in the engine field, working hard for long hours on end and doing it most efficiently and economically.